Welcome, ladies and gentlemen, to another edition of Binary Life, and today we'll be practicing jobs and cronJobs in Kubernetes in the Kodekloud platform. This is part of the videos of the many videos that are coming ahead for the preparation of my Kubernetes application developer certification. So let's give some seconds for the lab to load. So we have a lab here with 9 questions. We'll try to go through all of them. A pod definition file name throw dice pod is given. The image, let's look at the file. So this is the file here. Let's try to display the content of the file. Right, so it says the image throw dice. Here's the image used here. Randomly returns a value between 1 and 6. Obviously it's a dice. 6 is considered success and all the others are failure. Now deploy this pod and view the logs and see what number is generated. So let's try to deploy that pod. Let's apply that file. Now the pod is deployed. Let's try to inspect our pods and see. It has returned an error. So let's view the logs of the pod. So log, the name of the pod, I think it's logs with an S. So it returned 4. That's why we have a status of error. All right, let's go ahead. Question 2. Create a job using this pod definition file or from the imperative command, and look at how many attempts it does to get 6. So we'll try to get the syntax on how to create a job on Google. Let's just say jobs Kubernetes. Basically, it looks like the pod definition file with some minor differences. Jobs Kubernetes here. This is a small definition. We always have the API version, the kind, the metadata, the spec, and in the spec we're going to give a template representing the pod we want to create a job for. So I'll just copy this and I'm going to create a file called my job, a YAML file, and I'm going to put the definition file here, the definition of our new job. So it's a job, and the exercise says the name of the job should be throw dice job. So I'll copy this. Our editor here is VI, sorry. And the name of the image is throw dice. I'll copy the name of the image. Right, let's change the image name. And let me just give the name of the container to throw dice so that it can match the name of the job. This is optional. Not optional, you put what you want. So we don't need the command at this point. I'm going to delete this. Restart policy never. Backup limit, I'll just leave it like that. We don't need it here. Let's save and let's view our file content again. It looks like this. So I'm going to start it. kubectl get jobs. Let's just check the jobs that are available. There is no job, and the pod that is available, There is one I'm going to delete. That's the one that we created from the initial lab. I'm going to delete it. I'll delete this pod. And now there is no pod, and this is our file. So I'm going to apply our job. This one, kubectl apply -f. So let's check available jobs. We have one, and available pods we have 2 that has failed, and then we have a third one that is running. Let's keep checking and see how it evaluates. So we have 3 that has run, and we finally have 1 completed pod. So let's check everything is okay. Let's go to the next. So the next question is monitor and wait for the job to succeed. That's what we were doing when we were typing progressively this command. Now throughout this practice test, remember to increase the backup limit. Now what is the backup limit? I said check for the documentation. Let's check. Backup limit, Kubernetes, cronJobs if you want. It has to do with the number of times a pod has to restart and until we have a success. Let's just look at it from Stack Overflow. We can see something here. Backup limit specifies the number of retries before considering a job as failed. The default is 6. What does that mean? It means if we check again our definition file from our job, the backup limit is 4, which means if the job kept restarting 4 times and we had a failure, it will just consider the whole job as a failure. That's it. All right. Say check. Everything is okay. So let's go to the next question. How many attempts did it take to complete the job? For our scenario here, we had 3. So I take 3. Okay. Question number 5. Update the job definition to run as many times as required to get 3 successful 6. Right now we have 1 success, but we want 3 of them. So we're going to have to bring in another variable called completions that gives the number of completions that we want. Right now we want 3 successful completions. So I'm going to delete the job. Before that, let me modify the file. And just before the template for our pod, let me just add the number of completions we need for that template. Completions is 3. So now kubectl, this is the job that was there. Let's delete the job. Let's delete this job here. And let's check it's gone, and let's reapply that file. As the job is deleted, even the pods are deleted too. So let's reapply the file. Yep, this one. All right, let's get our job. It's back up. And what about the pods? We have 2 errors for now. 3 errors. The 4th container is launching. We have 1 completion, 2 completions, and we have 3 completions. We have 3 errors in 3 completions. So that's it. So let's check again. That's a good try. Let's go to the next question. How many attempts did it take to complete the job? Right now we have 6 for our scenario here. 6. Now that took a while. Let us try to speed it up by running up to 3 jobs in parallel. You will notice as we were coming one line after the other here, there was one job that completes and then the other one kicks off. But right now we're going to have to run 3 in parallel. So we'll have to bring in another variable called parallelism that permits to launch 3 jobs at a time. I don't know if I can spell it properly. Parallelism 3. Let's check the spelling in the job documentation. It's 1 R, parallelism. Okay. Three jobs are going to run automatically. So let's get our jobs again and let's delete the job. It's deleted. Let's check. It's gone. What about the pods? It's gone. So after applying 3 parallelism on the file, let's reapply our job file. We have a problem. Unknown field parallelism with the capital P. I think it's a small p. So let's modify that. Right, let's reapply. Great, seems to be running. Let's check that the job is up. And let's check the pod. So we can see that the timer is run. In fact, I'll come back to the explanation. Let's just keep inspecting. Normally we were expecting 3 completions and 3 parallel pods at the same time, but no more pod is starting. And why is it that way? That's because no more job is starting. Meanwhile, we have just 2 completions. We can see that in the beginning 3 pods started automatically. You can see from the timestamp we have 3 pods of 44 seconds. Of those 3, we had 1 successful pod, this one. Then since we had 1 successful, we're looking for 2 more. That's why 2 pod launch. And from the 2 pods we had 1 completed pod. So from there we're looking for 1 more. So what happened? It launched this one and then this one, and it didn't launch any more new one because we have like a series of multiple errors, so it considers the job failed. So we have to increase let's get back to the file. The backup limit of 4 failed jobs. I think that should be the reason. Yep, so let's delete the job. And let's relaunch the file. Right, let's re-inspect our pods. We started with 3 running. 1 is completed, 2 more has started. So this is the 3 running. 1 is successfully completed, so 2 started again. And of the 2 that started, we had 2 failures, which means obviously 2 is going to start again. Ahead. This is crazy. We still don't have completions. We still have 3 completions. 1, 2, 3, 4, 5, 6. And we have up to 6 errors. Let's modify that file again and try to increase the parallelism, the backup limit, sorry. Maybe to 9. Let's delete the job. And let's reapply that file. We're trying to have 3 completions. So let's reapply the file. And let's reinspect the pods. 3 started. And of the 3, 1 is completed. Alright. Here we rapidly had 3 pods. I think it won't start other pods again because we already have 3 completions. So let's check, validate. So notice how quickly that finished. Well, this finished quicker, but I think we had some delays with these restarts. Now the last one, let's schedule a job that run at 9:30 p.m. every day. Let's say, is it 9:30? 21.5 hours every day. I think it's 9:30. I don't know. So anyway, we have to look at the syntax on how to create cronJobs. All what we're doing here is just a job. So when you apply, it runs immediately, but this can be scheduled. That is where cronJobs come into place, scheduled to run at another time. So let's come to the documentation and look at the syntax for running cronJobs, and we will have to pick one example there, something like this, and create a cronJob out of it. So I'm going to create a file called cron.yml. So the name of the cron job is supposed to be this. And the name of the cron is at the level of the metadata. The name of the image is throw-dice. And this is the schedule of the job, of the cron job. (3021). This wasn't specified. We don't need the image policy. We don't need the command. And restart policy on failure. Well, let's just leave it there. So what do we have? We have the definition of our container here. And the container is encapsulated by the job, because normally a job launches a pod, a container if you wish, and then the whole job is scheduled in a cron job, which is encapsulated here. That's it. So let's apply this file. Before applying, let's look at the content again. Right. And I'll have to delete, I want to delete the former job that we're running. And let's apply our cron. Run progressively. Now let's check the cron file. kubectl get cronJobs. We have one that is running. Now let's check the pods. No pods yet, because this is not yet the time for the pods to launch. But anyway, this launched successfully, so let's check if we did the right thing and everything is alright. So this is the end of this practice lab. that has to do with pods, jobs, and cronJobs. One more time, pods are the building blocks of Kubernetes, where containers are launched. That's a simple way to define it. And then jobs is a way to schedule. Jobs is a way to make a pod run immediately after it's configured, maybe to accomplish one task like processing images. And then cronJobs permits the scheduling of these jobs to run at specific times, at specific interval, or at a specific day, just one time. So basically this is the end of cronJobs, and we're going to see another video practicing another lab for another section of Kubernetes. Thanks for watching, and don't forget to subscribe as more videos are coming till the day I finally get certified.